Okay, so this is kind of, I don't know, consider maybe the first visualization when people talk about what is first data visualization. There were other types of visualizations before, but this is considered one of the first, and it shows Napoleon's march to close to Moscow and back. And I apologize, but a few of these visualizations, at least the ones that are considered really iconic, have a morbid theme. And this one shows Napoleon's army. And so you can see everything that's gray, it's Napoleon's march towards Moscow. Everything that's black, they're coming back. And the data is shown, for the most part, this axis, the horizontal axis goes from east to west. So obviously, it goes this way on the gray and coming back. It goes that way on the black side of the march. Other than that, it's not necessarily geographically accurate. So that's one thing. Yes, it may have some geographical flavor in it, especially the east-west part, but it's not necessarily accurate. The visualization shows by width. So by how, sorry. If you kind of take a cross section here, you can see the size of Napoleon's army. So you can see quite a lot of them went that way, and they keep losing people. And there were fewer here, even fewer. By the time they got to Moscow, there were maybe 1/3 of the ones that started, and then they went back. And you can see how sometimes, I mean, this is a river, and something happened on the river. This is also a river, with things happening there. The story is, I think, that it was really cold when they went towards Moscow, and they weren't prepared for winter. And of course, there were battles as well, but the cold, the bitter cold, took toll. On the way back, the temperatures started to go up. I mean, I still think it was winter, but they started to go up. And obviously, there were no bridges were destroyed. So on the way there, they were crossing rivers by going on ice. On the way back, the ice gave in some of these. So I think this particular one here is an example of that. Some other thing that they point here, battles are marked. The names, I can't see them necessarily, but maybe I can zoom in some. So battles are marked, and rivers, just because, again, there were a couple of rivers like this one and this one where the ice gave in. And then you can kind of see at the temperature where it started to defrost, and it didn't go back enough for the ice to get thick. So that's kind of the story there. And it's a data representation, because you see the size of the army, you see how that army kind of gets thinner and thinner as they go in and come back. Over here, you see this branch. By the way, let me ask, and I haven't used this tool. You can see the blue arrow if you're remote. Yes, no, maybe?
Yes, we can. Yes.
Okay, good. Good, so I'll use that. Sometimes I draw too much, so that the pointer helps me. This is where they left some troops kind of for backup, and then they rejoined them on the way back. So that's kind of what you see here. This arm, but there aren't that many of these. So it's data, it's abstract. Number of troops is an abstract thing. Obviously, you can show pictures of them, but that would be the actual, but just putting it and combining everything into one visualization. And then a dramatic one, especially because you can see the beginning and end of the whole adventure. Well, it wasn't an adventure, it was more something I shouldn't have done. One thing I want to point out, as good as that visualization, at least people, the community thinks it's good. It's a good representation. It's not a perfect visualization in the sense that it's good for some things. If you want to see how the troops, the number of troops and what kind of various events that happen. But for example, it won't be able to tell me to answer a question like this. Here is my question. Do you think because it was really cold on the way there, do you think that the cold affected them? And obviously they weren't marching all the time. They would march and stop, and do something and, regroup and march some more and regroup and battle and then march. And so the question is, does the cold affect them more when they stay in one place or when they move? You cannot answer it based on this because you don't know when they moved and where they stopped. You kind of see that, the whole thing is glued together. So that's just an example where the task of that, a slightly different task makes the visualization less useful, almost impossible to answer something. And so that's kind of what happens. A lot of times I say avoid because I know from experience sometimes I have really good ideas. I kind of come up with a visualization and then have to find a problem for it to solve. It works that way sometimes, but it's possible, like I said. But normally you would have, rather than saying avoid, maybe a better word is make sure your task and your visualizations are in sync. So what you want to do and what the visualization does are in sync. So in this case, the example I gave you, it's impossible to do it on that visualization. But there may be other cases where you spend a lot of time, a lot of real estate, and that's probably the most important thing in a visualization, the amount of space that's taken on, let's say, displaying something, but your task only requires that in a limited way. So your users, or you, when you use it, you're going to have to kind of go around that space and try and deduct what's happening some other way. So you're actually allocating a lot of space to something that's not helping you that much, and then you have to use just a little bit of the space. One example that comes to mind may be a map. You're trying to see the order, in which you are trying to put states in order based on some metric. I don't know, the amount of rain they get. And you have a big map in front of you. Well, that's not going to, if you try to put them in order, it's not going to tell you that much. You have to maybe click on each and every state and remember what they were and kind of put it somehow on a piece of paper or mentally put it together. So that whole big thing that you use in your visualization, yes, your visualization can allow you to do that, but it's not the best solution. So ideally, you would have a sort button somewhere and not use that map. Or you may have the sort button, and when you sort them, they show up somewhere on a third of or in a quarter of the screen, you see something. So that's using too little for what you're trying to do. So bottom line, try to have the task and the problem needs to go with the visualization. There aren't that many visualizations that help for everything. Probably none, but I cannot prove a negative. So things to consider, what type of data, how big is the data that I need to process, and complexity of the data, meaning how many things for each data point do I need to show, how many interrelationships between the data are there, and then the type of users who's going to be looking. Some visualizations are really busy and they're really useful for somebody looking at, an air traffic controller. They need to see a lot, so they're paid and they're going to spend hours and hours looking at that visualization. But a manager, it's not going to look that much at that. They want get a higher level view. One other thing about the size of the data. I can have a data set that had 10 million records, but if I extract 10 of them and show them, what's the size of my data set? 10. It's not 10 million. There's other ways you process data and you actually reduce the size. You do an average per year of the 10 million records and you end up with, I don't know, 100,000. So that average already took away some of the data. So in fact, what you see on the picture is going to be it's going to be different than what you start. So when you consider that, I would consider the last step. I mean, that's an important step, processing data. It affects how the visualization looks and feels. But in terms of what data set am I representing? Well, I'm representing the 100K at that point. If I decide to group it some other way, the visualization size changes. So it's not necessarily, you don't look with what you started, you kind of look at what is encoded. What does the user actually see? And that's what would dictate how busy the visualization is, how easy to understand it is, and the data that's out there. This is a modified Minard graphic, and I need to zoom in a little bit. So it looks like it's September or so. Well, I don't know, as far as I can read. And we have the time in here going this way. In other words, and then the latitude, sorry, is that what? Longitude, east-west, going this way. You can see Moscow is all the way at the top, so that's the easternmost point, and then the west is here. Is anyone having problems? The image is what it is. It's an image. I can zoom in. Well, again, it's as clear as it is. I haven't built this image. I kind of pulled it up from something. Yes, letters are too small. It's not going to be on the test. It's an example of, I'm not going to ask you, I mean, I don't need to know necessarily the letters there. I'm just telling you what it is and how it goes. And then kind of going back to my problem. If the time passes this way and there's not a lot of motion up or down, what does it mean? It means they haven't moved, east or west. So this, for example, is an example of them staying in place. Then if I have a really brisk movement here, see how the time didn't change that much, but the longitude changed. That means they moved really fast. Here they kind of moved slower and stayed a little bit longer. Here is just staying in place altogether. Here is moving, and you can kind of see the speed as well. So the more it looks up, the more the speed kind of goes in there. Again, it's not going to be on the test, and I'm not going to necessarily answer the question, but this visualization would help me at least attempt to say whether staying in one place, they lost more troops staying or moving. I'm going to clear the annotations because they're in the way. So when they're moving here, it doesn't look like they lost a lot of troops. But the difference here is also moving, so it's kind of hard to figure that out. And in general, again, maybe it's not the best visualization. I'll explain that in a second. Why? But it will allow me to kind of look at it and at least try to understand if maybe there's no difference in the end, looking at that. But I know that there is no big difference. Whether they stay in place or they move, they kind of getting smaller and smaller at about the same pace. Say what? The y-axis is the longitude, east-west. So Moscow is at the top, the easternmost point. The question was, what's on the y-axis? It's kind of taking this picture and turning it that way, 90 degrees. So they start at the bottom, they go up to Moscow, and then come back. But the time passes, so that's why you can see the time difference between these two. In here. So this is the beginning of the campaign, this is the end, this is at Moscow. Moscow siege, whatever they tried to do there. Now, if they managed to get all these troops all the way to Moscow, I think it would have been a different story, because if you see, they stayed quite some time there. A significant amount of time they spent there. So they probably were doing some sort of a siege, and the Russian Empire was, I think this was before the communists, so it was an empire. They were defending them, their capital right there. Again, suppositions, not necessarily relevant for my question, but this at least has the time aspect in it, and I can see that there's not much of a difference as far as I can see. I want to point out another thing here with visualization, especially if I want to do comparisons. Let me focus on, again, focusing is mostly for the class. On this point here. That break, I mean, the other one where there's a big gap, I couldn't tell much because, which is this one here, because they split. Some force kind of went, and it's that backup force that stayed there to wait, to kind of protect them on their way back. That was their job. They left some rear guard. I know that. It's showing a different branch here, and that's the story, the history. So you can see how this moves at a different rate than the other. It's also on the other one, so something happens with the troop. You can see that some number of people go somewhere else. Yes?
Is this more like an overlay on a map?
There's no map here. This has absolutely no map component.
I mean, the way they put the points on there? I'm just
no. This is completely mapless. It has nothing to do with the map. Time is on this axis. Longitude is on this axis.
As far as, when you say longitude, are you talking about like the degrees?
Yes.
For a map?
Yes.
Okay, that's what I was getting confused on what that number represented.
It's how far east and how far west you are. That's all. It doesn't tell you north and south. Has nothing to do with north. You don't even see that. It's just a number of north and south. I'll explain that. That's a funny story. I'll explain it at the end. It's not funny. It's an interesting fact. So anyway, let me kind of go back here. Two interesting things to take. So first of all, this, like the question was, is there any map? No map in this one whatsoever. The previous one still has some map aspects to it. Like I can see some rivers, and they mention where the battles took place. And then I can see that they're going a little bit south and a little bit north here. So maybe there's a little bit of truth to how they moved, but it's not meant to be a precise map by any means. But this one, absolutely no map. The only map component, but it's not a component, it's just a number. It's an axis. It's the y-axis, the vertical one. Okay, so right here, the one that I mentioned, one of the problems that I want to point out is that visually, or it takes a lot of effort to try and compare those two, basically to compare the top of this one and see if this one is smaller. It's not as hard in a place like this. And here is the reason why. They're far away. And they start at a different position. So you kind of almost have to use your fingers to see how big this is and where it is. So our visual system is not good at doing that. So if the main purpose of this visualization cannot be comparing the sizes, it probably does a worse job when they're staying than when they're moving. When they're moving, it's easier to compare because they're right next to each other. The way this visualization is designed, you would have to redesign. I'm not sure I have a way, but I'm saying this is not doing it. So if I was really studying just the stationary points, this is not the way to do it. And it also resembles something that I want to point out on a bar chart. Everybody knows a bar chart, especially when you work on the project. You're going to hear me. It's very hard. I've seen many times, and I've tried many times, to beat pen and paper for solving problems. And kind of in the visualization realm, it's really hard to beat a bar chart. But if I have a bar chart and, well, let me make it really small. So I have a bar like this and one that's a little bit taller. I can see small differences when they're next to each other. So that allows a better comparison if they're next to each other. If they're far away, it's going to be harder to compare. Also, the other thing that makes a bar chart easy is the fact they all start at the same point. They all start there. If I start dropping bars floating in space, which one is taller? It's harder. So you lose our visual system loses the ability to compare. So it all depends. It's kind of it depends on the task, on what you're doing. So I would say that this visualization helps me best look for speed and how many soldiers were there. Kind of, it allows me to make small comparisons on when they're in motion, kind of see, yes, they're decreasing or no. Secondary, it's going to be when they stay in the same place, just because they're further apart, the way the visualization works. So that's kind of a secondary task for this visualization. And it also maybe kind of allows me to see if there would have been a big difference between the two conditions, moving versus staying. But it doesn't seem like it's there. It's kind of continuously chopped, they get continuously smaller and smaller and smaller. And that's in the data. And if the data would be different, I think this visualization would show it. I kind of believe that. But that's what I'm seeing right now. No big difference there. But that's kind of how I would analyze the task that this visualization allows me to do versus. Now, the color is really, if you can't read it, I'll tell you, it's temperature here. So the temperature is red on that side and blue on the other, blue on the positive and red on the negative. And this is Celsius. And here is the story. I found this in I think maybe a precursor for Tableau. Kind of, there was a research I wanted to say Carnegie Mellon. Really, I forgot, but it's an Ivy League school, but I want to say Carnegie Mellon. And those guys at the time decided, can we build an automatic visualization tool? And they were in the School of Business. So their automatic visualization tool, you just basically plug in a table in a data from a database, and that visualization tool would decide how to represent it. And that was one of the examples they put in the paper. In business, if it's negative, how do you represent a negative dollar value? Red?
Red.
You're in the red.
Red.
So, and if it's positive, it's blue. Now, in temperatures, it's completely opposite. So the meaning here, the computer didn't know the meaning of positive, negative, and their program assumed kind of a business or more of a kind of that kind of database where positive and negative would be on the flip side. A lot of the scientific data, it's probably on the opposite. So if it's really hot, it's that way. If it's really fast, it's also you're represented by red, and blue tends to show cooler. But that's the story. So this is automatically generated by a tool that looked at, they kind of created this data table with Napoleon's March, and the tool looked at it and pulled up this visualization. And it helps me kind of explain this concept of task, kind of where does my visualization fit in? What is it actually doing? And their old visualizations are probably going to be good at something, and they're going to have some marginal effect on some other problems that you can solve, and then not going to help you with anything else. Another kind of famous visualization here is Florence Nightingale's nurse. I mean, she's credited with pretty much starting the whole I mean, there were nurses before, but she kind of made people aware that that's actually a profession and you need to take it seriously. And this is one of the diagrams she showed probably to the British Parliament to convince them they need to kind of, I think, take some hygienic measures in the hospitals. I think at the time it was even to the point where they were, and she compared hospitals in London or England with hospitals in Crimea. Current affairs. But at that time, British Empire was fighting probably the Russian Empire in Crimea or the Ottoman, somebody there. It was a big fight. So they had army hospitals. And I think in the army hospitals, they didn't care about hygiene to the point where they would even not change sheets. You know, treat one patient, one soldier, next soldier, come in. Set them on the same thing. So it was really bad. And she was trying to say, we need to do that. And so that's the comparison here. And again, I know it's not clear. It's not going to be on the test. And I don't have access to the original visualizations, whatever I could find. This is one of the clearest. And the other one I pulled from the paper. So it was a screenshot. I pulled it from the research article they published. So that's why it's not. I'm just demonstrating so you see what's out there and kind of establish the concept. What we see here is a number of months. If I zoom in, you can see May to June, June to July, July through September. So in the summer, it's not a problem. Kind of starts to be a problem in the winter. So this is July through September, and then so each of these. What did I select? Each of these pies represents number of deaths in the hospital. And I think this circle may be the England or the base case. Kind of what was happening, rate of deaths, and then compared to what they were doing over there. So you can kind of see the number. So actually the radius is what gives us the number. So the more you go there, the more deaths in that case category. So that's kind of what you look for. I will later come back and tell you that this is a little bit, I understand the point, it's probably for a good cause, but it's a little bit misleading, this visualization, and I will explain once we I'll come back to this one. Okay, so again, this is a famous one. It kind of shows the need for taking measures, in the hospital. The next topic is something I would like to talk more in this class, but I never get to it. So it's towards the end. I think if you go to the lectures, it's there. I haven't updated those in a while, though. So text visualization, and the other kind of related to text, but doesn't have to be necessarily, is something called software or program visualization. So you can see how a program runs and see if it makes mistakes. You can see how a program was developed, like over time, and we have now. You can take a big repository like a GitHub and look at the changes and see when they occurred. And this way you can kind of track down. It helps you program, it helps you do debugging. So I have these two topics I never get to, so I figured at least I'll give you the examples here. Plus, they're cooler than the more statistical ones. They look cooler. So kind of visualization of text and or program. I'm kind of introducing both of them here. And this is a little bit of change I made versus the old recording, because whatever I had here didn't work anymore. So Tarantula, that's software visualization. It's used to detect bugs in a program. And if you used it once, you probably, I think it's relatively easy to use, but it takes longer to explain than to actually use it. So here's what we're looking at. This is an entire program, and I think it's some sort of code they wanted to put on us. It's from European Space Agency. So it was a piece of code, something to do with satellite in orbit that I remember. But it's a piece of code, and they kept developing it, and it needs to keep the satellite out. And the way this software works is it assumes that you take the code that you want to debug, and you kind of go through a suite of tests. So you give it, in this case, it kind of at the bottom. Somebody's mic is hot. Dean, I'm going to mute you.
That wasn't.
Oh, it wasn't you?
Yeah, I was muted, I thought.
Anyway, that was the only mic on. So in this case, they went through 300 of these inputs, and they kind of know what to expect at the other end, if it's a correct move or not from the satellite. If this piece of code performed correctly or not, they know. And if you can do it automatically, you save a lot of work. Kind of you go through all of these and you see, was it correct or was it not correct? So here at the bottom, you can see the 300. And you can see that this particular line of code, which probably this if statement that's selected there, was executed every time the program failed. The program failed 3 times. The program failed. Yeah, no, I'm wrong. I don't know how many times the program failed. But for this line of code, out of the 300 times the program was executed, the line of code was executed 66 times out of 300. Why? Well, again, those of you who kind of are not that much into coding and software, there's this saying, I heard it in different numbers, but basically 70% of the time, sometimes 80, the code executes 30% of the code gets executed. So there's a lot of code that it's written and it doesn't get executed, almost never. For example, you open up Chrome, you keep opening it up and it still works. It shows you the web page, or web page, or web page, or web page. Now, your internet goes down, and maybe this didn't happen for the last 30 days, but the internet goes down and suddenly you open up Chrome and it tells you internet is not connected. So that piece of code that displays internet not connected, it has not executed previously when your internet was connected. So that's the reason. That's why I say there's a lot of code that doesn't get executed all the time. and actually, like I said, most of the code doesn't get. It's in there to kind of take care of things that happen rarely, but it needs to take care of those when they happen. So that's the reason, that's what you see in here. So this particular line of code was executed only 66 times out of the 300 executions. And actually I lied, I know. So 63 times out of the 66, it was when the program executed correctly overall. And then 3 times out of the 3 errors, so the total number of errors was 3. So the program executed correctly 297 times, but failed 3 times. So there's a bug that doesn't show up that often. It's one of those, it's hard to find. Because, it depends on certain conditions, it happens, other times it doesn't. But this particular line of code was executed 3 out of 3 times. Okay, so that tells you there is, well, it's not necessarily that this line of code is wrong, but maybe other pieces of code that led to it are wrong at some point. Okay, so at the bottom here, I can see the actual line and even a little bit of the neighborhood of what that line does. And then I don't have it necessarily. I don't know exactly where they clicked, but they clicked on the whole program is shown right here. So this is the first line of the program, second line, third line. Each of them is 1 pixel wide or tall, if you want. I think it's a better term would be tall. So each of them is 1 pixel tall. And then you can see that it varies, the length varies. Basically, it varies with this. So they kind of take this and make it smaller. So you still see the structure of the code. You can see there's some if statements just because the way it's written. And you can see some things are nested inside the others because they start like this part here. They start a little bit more to the right. Gives you a bird's eye view of what's happening. And here is the entire code represented there. So now they kind of make use of the color in an interesting way. They use the amount of color they put in to represent how many times that instruction was executed. So the gray here was never executed in these 300 sets. So there's pieces of code there that were never, they didn't get to be executed. And in a way, you don't know if they work or not. These bright ones, like right there, or there's some green bright ones here, they were executing quite a lot. That's why they kind of really bright. Here's your kind of color scale. So you go this way. It's the more they get executed, the more color they get in. And then obviously the ratio between pass and fail is going to show up this way. So if it's only executed when it runs, like these greens here, then that's what it tells. It's green. It's always, every time that instruction was executed, there was no error. So they must be good. They're not doing anything bad because they never got involved with the red. If it's yellow, it's in the middle. It means they were executed almost every time. Think about print. Like the print function, almost every program prints. It doesn't matter if it runs correctly or not, you print something. So think of it that way. So that's a piece of code that's common. The error may be in there because it got executed quite a lot. And then the other ones, you can see the bright reds here. They were executed only during the 3 times the program failed. So if I start debugging, I would start with the reds and kind of work my way through there. And like I said, once I explain it, it kind of makes sense. And I would pretty much ignore the greens and ignore the parts that are gray. They're not going to help me fix this bug. There may be other bugs there, but not this one. So that's kind of a text visualization. It's text visualization because it shows program. It also helps us debug. Like I said, not all of them show programs. Some visualizations may show how the program works, like how variables change. Variable I is 1, then it's 2, then it's 3. You kind of see that changing. So it shows more numbers than anything, but that's tarantula. Text visualization, kind of a big area is to look at what did I say? I want to say collections of documents. Those collections typically kind of see what themes show up in a document, and then group them. And there's this idea of self-organizing maps. It's one solution they can do with the documents and place them together. So in this case, there's this company I got there. They have it on their website, Lingo4G. And it looks like they did a search on influenza mice, and you can see how topics show up in various documents. Here are examples of documents where they get them from, either medical report. I mean, it can be any kind of document, a text document. But you have a collection of them, so you extract information, and based on how, basically most of these would look at some sort of keywords, and they do an analysis of those keywords. How many keywords show up in this document? How many keywords show up in this document? How many are related to each other? And based on that, they put it here. So you can see meningitis and conjugate vaccine. They're close together, but they're far from influenzae. And then intradermal hepatitis B is where they occur in. I think that's one way to get hepatitis B. You use a needle that somebody else used and had the disease. This may be AIDS is in this area, and then reinfecting seropositive, all these. So this is how documents kind of get together. I don't know exactly how they encode information. There's kind of many ways. You can extract a lot of meta information out of these documents. One is obviously the topics. So all the documents in this area here are going to be about hepatitis B. That also tells us, that intradermal is right there. Next, there's a lot of documents that talk about both of them somehow, and that's why those two topics are put next to each other. You can see here something that kind of resembles mountains, like a map with mountains. Like I said, they can do anything, but here is my 2 cents. What I would think that represents is how many documents are that talk about that particular topic. But there are 2 things to consider here: is height and kind of area on the map. The height, obviously, we don't see it because they grow towards our eye, on the kind of out from the screen towards my eye. But I can see those contours, and they kind of tell me how high they are. So those 2 different people, you can customize. I mean, different tools can encode different things. But one common thing would be to the height. I need to give you an example. So let's say I have an article about economy, inflation. It talks a lot about inflation. Last paragraph there says something about Biden, President Biden. Is the article about President Biden? No, it's about inflation, but it mentions President Biden. Then I go to the next article. They talk about, I don't know, child credit. They talk about child credit a lot, tax credit, and then they also mention President Biden a little bit. So you can see that some of these terms show up in a lot of places. They have a lot of, they show up in a lot of articles, but the article, they have a low frequency in that article. So to me, if I were to represent it visually, the area would show kind of how many of these documents mention hepatitis. They may not be 100% about hepatitis, but they mention it. And then again, if I were to design it, I would make the height on how many are high frequency on that, how many really talk about President Biden. There may not be that many, if it's an economic collection of documents that talk about the president especially, but they talk about other things, and they mention the president being there, one of the factors, they mention it there, or the Federal Reserve shows up. So the height, there may be a topic with Federal Reserve, but the height of that may be lower just because there aren't a lot of documents that only talk about Federal Reserve or mostly talk about that. So these are two things you can consider when you look at these maps. And I note that this one also uses color for something. Oh, for the, I guess they give each topic a color. You can see there's an article here, maybe about tetanus in the measles. I don't know. I'm guessing, so there may be a way to do that. Here is kind of the same thing in a 3D view, so you can take that map and actually build mountains and ranges. And here they're kind of using a different encoding. They say that, and this is a bunch of articles from Yahoo about corporate, about companies. I haven't read too much into detail. Again, I'm not showing, it's not going to be on the test, but it's about companies and kind of what their areas. And so each cluster has internal similarity. So the companies are similar to each other in what they're doing, then that cluster will be told. That's kind of how they do it. Again, if it's a flat Earth thing, that means they're not necessarily that closely related. It's kind of the same thing with Biden. There's a lot of articles about Biden, but they're not really high frequency, all of them, about it. So maybe that's kind of the same way I see it, but I'm not 100% sure what he means by internal similarity. That's how I interpret it. Grayscale is internal deviation. So darker means they're closer to each other. Brighter ones, they tend to be further apart. And then they use volume to the number, peak volume to the number of elements in the clusters. That's another representation of the same concept. I have a bunch of companies, and maybe that's what they find in their business description. Or this is kind of an older one, same concept. Something like, I think they took what CNN has been talking about in the year, I don't know, 1990. I'm making up the year, I don't know necessarily, but it's topics that you see on the news. How would you visualize the news for one entire year? That's one way. There's others that I've seen. So you can see, again, things that are, one thing, definitely things that are closer, they're, you can see that China and Hangzhou and Dam Buddhist, they're kind of in this area, and then you have labor and Charles de Gaulle and British, well, Charles de Gaulle and Cruz France on this one. Obviously, Charles de Gaulle was president of France at some point. So if they're close to each other, they probably are related. They have some documents in which both of them show up. So it's kind of giving you a bird's eye view of many, many documents. Oh, this next one, it's something kind of we did here. I will, while I talk, I will share my screen. The idea of that was to we were doing a project with the Air Force, and they basically said, well, what if we have, obviously we didn't look at any classified data, everything was publicly available, and you would see that it's actually kind of like Google Earth. But they said if we fly a satellite or a plane over high altitude, and we take images and we see people on the ground, Should we send, the army there, or, the police to take care of it, or just let it go? And one solution I had at the time was like, why not see what people are saying on Twitter about that area? And we kind of took this Google Earth view and queried Twitter, and then tried to figure out where the tweets are coming from. Nowadays, at that point, a lot of people were not, they were using their phones, but they weren't GPS enabled necessarily. So maybe even now you're not all tweets are geotags. I think numbers are getting higher, but it's, at the time, I think it was about 20% of them were geotagged. But then we started looking inside, like the text topics, what people were tweeting, and try to link that to various geographical locations pretty automatically. I was thinking there would be a lot of noise. There was noise, but not as much as I expected. And then the problem was, how do I visualize that and correlate what you see on a, from a satellite with what's on Twitter? So that's kind of the view. Again, it's like Google Earth, but it's open source, so I could get into its code and modify it. As we get in closer, I'm starting to see the tweets showing up. And it's really, it doesn't show the tweets necessarily, but the keywords that are occurring frequently. And think about New York. There's a lot of people talking about a lot of things in New York, so I cannot take, if I only take like 10 or even 4 of the New York topics, I cannot put them on top of each other, right on top of New York, because they will basically be on top of each other, and you can't read them. So one thing we did, we kind of splashed them around. If you look through it, we have a center here, and then 2 concentric circles that show up. So that's kind of for every geographical. Already these maps, the way they're set up, they kind of come up in tiles. But if you have a slow internet connection and you go to maps, you kind of see how these tiles pop up. They get loaded at different levels. So we used the tiles that were already there and just laid our information. So one thing, we can see something. It's not precise. Right now, it's not. I mean, I see they talk about the US. But as we fly more, we see more information. And in the relative area where they show up, and at some point I'm going to get lost on this map. So that's one way, kind of zooming in, we get more precise tweets from that region only, and kind of, you can see they're getting better displacement and kind of what people are talking. So we're starting to, all these national things go away. We can start to see regional. And at this point, it's where I start to get lost. Not now. I'll go into Mexico, and that's the map looks different when you go to Mexico. I think when I recorded this, my computer was starting to be so slow, it was a pain. What happens if I click on one, if I mouse over one of them, I see where tweets are coming from. You can kind of see I have cones that pop up. So if I see a word that I'm interested in, I can kind of go and mouse over it, and then it shows me where all the places where it shows up on the map. But you can kind of see way in the distance, just because the 3D view. You can see on if you look on the horizon, you can see that topic also shows up in other places. Other things we tried to do, well, no, we implemented that. It's not in this video, but we tried to look at interesting things. I mean, you would fly over things. In Denver, one time I could read couch, garage, fire, fireman. Somebody probably had a couch that I didn't really search the tweet to look for it, but On some of these, you can make it out. You can see what's the important things, like ferry accident, things that you don't make national news, but there was ferry accident somewhere in, I don't know, close to maybe Toronto, that area. What else? Oh, we started putting, I wanted to encode time to see kind of different topics. Because time will tell you, you're not going to mix them up. So to encode time, and we actually did that. We started using size of the text. So topics that were older than 1 hour, kind of every hour the text will get smaller. So big text shows up, and you know it's current news. We tried to do that. That's what we didn't implement. I tried to kind of put an animation on it, so you see the topics getting smaller and disappearing. But that we didn't get that past, and it's not part of this version that I selected. Plus search tools. You can see as we go up level, you know, the topics tend to be more national. They show up many places. Go down. And that's pretty much it. You can think of it as a filter, as a search tool, not necessarily a visualization tool. You're searching for tweets by just moving through the map without specifying stuff. Let me check one more thing here. Not that one. I want to check one. I want to see when to stop, basically. Let's see if kind of got enough. Not stopping yet. We'll keep going, and then we'll take a break after. I think I want to go to slide 28, so 3 more. Maybe I'll stay here because it's not on this one. I think I don't have to annotate much. Okay, so those are some examples which I think are cool, especially text when you visualize some of the things. You know, if you look at sales per quarter, that's kind of a, I don't know, maybe I'm biased, but it's a boring visualization. It's a useful one, but it's not. Some of the other ones that when you kind of start looking at text or other more abstract data, they get more interesting. You have more freedom to look for. So also on the visualization, we have 2 sides. We have the computer side, and we build a visualization, and we have these techniques, and we do all this stuff. And then you have to also consider the person who's looking at you're building it for a person. If you want a server to deal with it, you're not going to give it a visualization. You can run an analysis, you know, that's going to be more statistical oriented. This one assumes that there's a person that needs to look at that visualization, and that's why we're looking at that data, you know, solving a problem with people's help. There's a whole field called visual analytics that it's kind of a mix between people and computers. So the computer does something really deep behind the scenes, but still the result is visual, and the person directs it and validates it and so forth. So on the human side, and that's the reason why visualizations sometimes are, they don't behave in a, you can predictive manner, just because people are not that easily predictable. So if, in other words, I have 2 visualization techniques that work well and I combine them, it doesn't mean the results may be complete garbage. Nobody will understand what's going on, or they won't like it. Although individually, each of them is really nice and people love it, put it together, it goes away. So that's kind of the problem a little bit with visualization. There's a name for it in systems theory, but here is my my reference. It works kind of like if you have a lion and a chicken, you put them together in a you're left with whatever else is there. Or chocolate and dogs, put them together, and both are messed up at the end. Okay, so that's kind of the problem of composition. The composition is not linear. The, whatever we have, you cannot just take some part of visualization and recompose it and get something working, or put two together and assume they will work. So that's kind of my analogy with what it goes. So they're not easily. It's not like a component. You cannot break it down into components. But on the human side, first, people are also, they need to understand the visualization. It needs to help them with their problem. So how does it work? I kind of mentioned in the earlier in this set of slides, that it increases mental resources available. It's almost sometimes works like a hard disk. You don't have to remember the information, it's right in front of you. Or you annotate it. You mark the things that are interesting to you on the visualization, and they get selected with a different color. So that way you'll find them later. So you don't have to remember everything. But it also helps us because our visual system a big part of our brain is visual processing. So almost separate, well, loosely related to our conscious mind, it's this visual system that will process information for us. So what can it do? We can scan through something like move your eyes and go up and down and scan through the data to look for a certain thing that you know or you think it might be there. Filtering in the sense that not all filtering happens visually. Actually, some busy visualizations may, if there's too many, especially if you think about too many things moving. You're driving, and there's 4 cars, all coming from different directions. One stops the other, the lights change. All of these changes, actually, our visual system is not good with it, filtering those. What we're really good with filtering is, maybe I should call it segregation of background versus foreground. We can separate it. So things that appear to be in the background, our visual system almost instinctively ignores them. Things that appear to be in the foreground or affecting us, evolution. A bear coming out at you, you're not going to admire the flowers behind the bear. It's going to be, okay, I need to do something now. So that's kind of the thing that we're good at. Like I said, not necessarily filtering in the sense that, if there's too many bears coming at you, you don't know what to do. And we also, because of this thing that we kind of filter out some information or ignore it, it's not necessarily conscious that what we filter. So there's this concept of blindness. There's many types. I mean, you probably can take a psychology class on this and have a whole semester to talk about different things, or at least 3 weeks. I'm just going quickly through this. So 2 things that are mentioned in the book is this inattentional change, inattentional blindness and change blindness. I think I'll go with change blindness first. And before I go there, I'll get back to it. The other thing we can kind of do pattern recognition. We can recognize patterns. We're pretty good. Our neural networks are pretty good at doing that. So we can identify, especially a person's face, even if they're upside down or from a different angle or at night. You say, oh yeah, that's John. Nice, that's Eddie. They can be bigger, they can be smaller, they can be dressed differently. So we recognize some patterns even if they're not as clear. And again, this is a double-edged sword. The pattern may not be there, but it looks to us like it's there. It's like, like that thing with you look at the clouds and you say, oh, that looks like a ship sailing and a shark on the clouds in the sky. So it's not that, but our mind kind of goes and tries to attach this pattern to it. So we can recognize them, and if it's done properly, it can help us kind of go through the data and recognize things that that makes us understand the data. And it can be also kind of, like I said, inadvertently may give us something that's not really there. And it's some people, not everyone, but some people are visual learners, and that's why you find images in all textbooks. It's easier to remember them. So if you want to memorize something, it may be easier through an image than through other methods. Now on the blindness. If you look at the picture there, I will switch to the next slide and then try and tell me what's changed. That is about change blindness. So it's something changed, but it happens suddenly. And I don't know how many of you figured it out. Look here in this area. That's quite of an important thing that disappeared, the engine. But again, it's kind of in the background, too many moving things, too busy of an image, we don't see it. How can you fight change blindness? You can cue any change. If that engine would have flashed 3 times and then disappear, we'll say, or if it moves, if it starts moving towards the end of the... So there's cues that you can do to cue the user that, hey, there's change happening. Now, again, if the data changes quite a lot, like I'm looking at 100 cities and 50 of them change, there can be too many things moving that we're not seeing. So that's change blindness, and inattentional blindness is next. It's this one here. Let's see if it works that way. I think so.
This is an awareness test.
Okay. Now, I've seen this in other situations, so you may have seen it before. If not, it's pretty fun to watch. But it kind of illustrates this point of blindness. So it's an awareness test. I'll let it go. And let me change the mic setup so maybe it picks up the sound better.
How many passes does the team in white make? The answer is 13. But did you see the moonwalking bear?
That's the bear. Great. Actually, I've seen a video that takes it one step further. I'm not sure it says. There's inattention to inattention or something. Selective attention test. But the idea is that if you're not looking for something, you may not see it. And again, it has to be more, deal with more with animation things than changing visualization. Than necessarily with static. So that's the tracking perceptual attention, and it allows us to manipulate information in the sense that I can change it, I can move it. Sometimes I can grab objects and change them, what they're doing, put them together, and so forth. That's one advantage. Is visualization working? I mean, not for everything. For example, I'm not sure if it's in the previous slides, but if I'm trying to represent, to explain to you what their derivative is, I'm not sure if I can do it through visualization. Mathematical notations sometimes are very powerful, or quantum mechanics. It's a lot of mathematical notation that you put in there, and our mind can abstract things and kind of deal with that notation. So not all problems can be solved by visualization. That's, take that with a grain of salt. That's always, so it's good you take this class because, you know, different, you're trying to, one thing I can get, maybe you can get out of this class is when does that, it's actually useful, when it's not. Again, dealing with people, but sometimes there are notations out there that are very powerful and that, you know, are better than data visualization of the data. But there's various companies there involved. Spotfire, Insight. Insight was bought by Business Objects. Business Objects was bought by SAP. And I don't know if SAP is still, they're probably still, it's a huge company now. They kind of keep getting bigger. Tableau is already there. Spotfire, no, Microsoft has it put in. There's this Pacific Northwest National Lab. They have a visual analytics center. Thank you. Move the mic back. Yes. So yeah, there's companies make money. There's visual centers that they came up with this idea of visual, or a whole call for visual analytics a few years ago. They had a whole document. There's, you go to look through you know, National Science Foundation, things that give grants, and they do give some money for visualization. And like I said, certainly not for everything. And even when we know they work, it's kind of hard to evaluate just because you have a person at the other end. So to evaluate a visualization, it's not necessarily a technical thing. It's, you have to evaluate with the people. So there's, again, I think I have a whole set of slides on evaluation that I will never get to this semester. But that's kind of like conducting any psychological experiment. You have to, you set up trials with people and kind of see what works, what doesn't. If they can solve the problem or not, how fast, how many mistakes they make, things like those. Modify how happy they are with the visualization.